Hi, welcome to the installation tutorial and introduction to doing rescue line for Webots. For those of you who don't already know, Webots is a simulation environment in which you can emulate various real-world settings. For example, we can simulate our robot line tracing and completing an evacuation zone as you would for regular rescue line. In this video, we're going to tell you how to download everything you need to run rescue line in Webots, and we're going to get you started on tackling this competition. So the first thing that you want to do to get started is download both Webots and Python. To download Webots, go to cyberrobotics.com, which will be linked in the description, come to the middle of the website, and hit this drop-down arrow. And select the operating system that you're working on. So Windows would install the Windows installer, Mac would install the Mac OS bundle. From there, it will download an installer, which you can run, and that will download Webots on your computer. To download Python, visit the Python website, which will also be linked in the description, and go down to one of the Python releases. So if you want to be extra safe, Rescue Line for Webots was built using Python 3.8.6, so that's guaranteed to work. However, the Webots website also says that it supports all the 3.9s, so either of the 3.9s should also work. After you click on one of these releases, again, like Webots, it will download an installer, which you can run to install Python. It's very important that while you're working through the Python installer, you click Add Python to Path. So when you run the installer, there will be a box that appears on your screen. And as you click through, make sure you check the box that says Add Python to Path. If you want a step-by-step tutorial on how to install both Webots and Python, there will be a video linked which goes through how to install both Webots and Python step by step. It's made for another competition, but it's also applicable for this one. And if you do watch the video, all you have to do is go through the first two steps of installing Webots and Python. From there on, the video will differ from this. The next thing that you want to do is visit the GitHub repository for Webots-Line. The link to this will also be linked in the description. Here, you'll find all the files that are specific to running Rescue Line on Webots. To download all this, you're going to go to the code button and hit the drop-down arrow, and you're going to hit download zip. And this will download all the files within this repository as a zip file. So then we can just click on it to open it when it's finished downloading. And then you're going to click on the downloaded zip folder, and you're going to go to compressed folder tools if it doesn't go there by default. Click here and then click extract all. Mine works a little bit different, but after you click on extract all, you're going to select a folder where you're going to save everything you download from this GitHub repository. It's pretty important that you remember where you save it. So what I'm going to do is I'm going to hit extract, and then I'm going to find what folder I want to download it to. I want to save it right here. I'm going to hit OK and extract. From there, you want to navigate to where you unzipped your folder. So I'm going to navigate to this folder. And as you can see, my downloaded repository is right here. I'm going to go into here. I'm going to go into the worlds folder. This is where all the worlds will be stored. So when you're using Webots, every world that you create is going to be saved as what's called a world file. So let's say I create one world file to have a robot, and then I save it. It will appear here as one of these files. So we're going to open up the sample world. And depending on the amount of time it's been since between the time you download this and the time this tutorial was made, some of the worlds may be named a little bit differently. So just keep that in mind that when you open up the sample world, it may not be this exact world, but I can promise you this world will be inside here for your testing ability. So as you can see, it opened up Webots. And if it's your first time opening up Webots, it may ask you to set a theme or something like that. That's all perfectly fine. So when you open up Webots, it should look something like this. If it doesn't look exactly the same, that's perfectly fine. There are some variants. So to briefly introduce you to Webots, there are a few windows that you see in front of you. The probably most important window you see is your world view. So this is the center window right here. Right here, you can see your world and everything inside of your world. So there are various objects placed inside your world. There's a robot, there's a bunch of tiles, there's lines, there's balls. There's a lot of stuff going on in this world. To navigate through your world, you can zoom in and out using the scroll wheel. You can rotate your world by left clicking and then dragging. And then you can shift your world view by right clicking and dragging. Right? And basically inside your world, this is where your robot is going to interact and complete the challenge. The next window we can talk about is your text editor. For those of you who plan to use text-based languages for writing your Blockly programs, you can use Webots' inbuilt text editor to open up various files with this open file button. And then basically you can find your .cpp or .py or .java file and open up in this text editor. However, since this text editor doesn't provide much space, it may also be a good idea to open up your file in a separate IDE, maybe Notepad++, doesn't exactly count as an IDE, but some other text editor, so you have more space to work with. Just for this competition, a quick note that if you plan on using a text-based language, you can pick from any language that Webots itself supports. So this would include C, C++, Java, Python, and MATLAB. Right? The most common languages are probably C++, Java, and Python, and those have the most documentation on it. So I would probably stick to these three main languages. So this text editor is where you can open up various files and programs if you want to. If you don't plan on using the text editor, you can always just exit it out, and that gives you more space to analyze your world. This window to the left over here is called a scene tree. Basically, a scene tree is a list of all the objects inside your world and their properties. For example, we can see that we have a robot in this world. So for every object that's in this world, you will find it as a bullet point in this scene tree. So as you can see, when I click on it, it lights up inside the scene tree. So this robot is represented as player 0. You can click the drop down and there are a list of many attributes that you can start reading through. For example, translation is your robot's position within the world. Rotation represents what direction your robot is facing. Scale is how scaled up or down your robot is in size. And then this children is probably a pretty important attribute you want to pay attention to. Under children, there are two groups. The first one is the default group. If you go to the Webots documentation and you look up its robots, you can find that the Pioneer 3DX comes with a few default sensors inbuilt onto it. And if you hit the drop-down arrow on the default group and hit children, you'll see all the motors and sensors that come by default with the Pioneer 3DX. If you hit the drop-down arrow on the other one, the extension slot, and then hit children, this is where you should add all sensors and I guess additional motors if there's no real reason to add additional motors. But if you want to add anything to your robot, then you should definitely do it through the extension slot group under its children. So as you can see, we've already added a few sensors for you to play around with. So that's the scene tree. It's just a list of all the objects and their attributes within this world. The final window is the console window down here. Basically, this is where all your print statements go. So if your programs do any print statements, they will get printed out here. They also give you world messages, so you can see these warnings. That's fine. You can ignore these, and then some compilation information such as this, and etc. For a more detailed tutorial on how to interact with Webots, we'll post another YouTube link in the description, along with a time frame of what minutes you should watch to learn information that's relevant to interacting with Webots for Rescue Line. Now, since the video was made for a different competition, you may see and hear some things that you don't necessarily see or hear for Rescue Line. For example, there will be a window off to the left that you'll see in the video that you won't see for Rescue Line. This is because the window, the left-hand window, was relevant for the other competition, but is not necessarily for this competition. So if you see anything in the video that you don't see here, that's fine. You can just ignore them. We'll show you how to get everything set up for Rescue Line in this video. Now, there are a few windows that you might not see in front of you by default, but are pretty important to Rescue Line inside of Webots. The first one is the game window. To open up the game window, you're going to navigate to the scene tree and you're going to click on Def Game Supervisor Robot. You're then going to right click on it and click Show Robot Window. And you will see a new window appear. You can always resize it by going to the window's right-hand border, clicking and dragging. Now this may look different depending on when you download the repository, but the same idea applies. You will see a lack of progress button, and this basically is for calling lack of progresses. So if your robot is running through its course and it maybe falls off the line or it gets forced into a situation where you need to call a lack of progress, you can always click the lack of progress button and it will reset the robot back to the beginning or the last checkpoint that it's been to. These checkpoints are represented by these yellow cylinders. And if you ever want to reset the game completely such that your robot doesn't go back to the last checkpoint but actually goes back all the way to the beginning, all you got to do is exit out of Webots and reopen this world. That will reset everything. Down here, you'll see various categories such as obstacles and intersections, and you'll see an add and a remove button. What you can do is for each obstacle you see in the world, you can display the appropriate amount of obstacles that you need. So for example, there are 2 obstacles here. I can remove 1 obstacle from the list. So I can hit remove and confirm. Right? Now I have 2 checkboxes for the 2 obstacles. And for intersections, I can add a bunch of intersections for each tile that involve intersection. From there, I can click the checkboxes depending on what elements I score, and you'll see my total score increases. So this is the game window. The next window that may be of interest to you is the Blockly window. Now, whether or not you use the Blockly window is completely up to you. What Blockly is it's an extension added to Webots where you can use drag and drop programming to write controllers, robot controllers, which are just programs that control robots, where you can write robot controllers using drag and drop blocks. And then you can load it on to the robot. If you don't choose to use Blockly, which is the drag and drop feature, then you don't have to worry about this Blockly window that we're going to talk about in a second. You can just stick to writing your programs in whatever text-based language you want to use, and then submitting them normally through Webots. However, if you do want to use Blockly, you can go and click on Blockly Supervisor Robot, right-click, hit Show Robot Window. Okay. And since there's not a lot of room here, you can either exit out or you can undock the panel so it floats as its own window. Right. So now I'm going to expand this a little bit, and I'm going to close this out. And this right here is the Blockly environment. Here you can use a bunch of different blocks and use these 3 save, submit, and restore buttons to load the code onto the robot. There is one very important thing that you do have to keep in mind when trying to upload your Blockly programs onto your robot. That is, you have to make sure that this robot is actually connected to Webots Blockly. To do so, go to your scene tree and hit the drop down on your player robot. Scroll down until you find the bullet point that says controller. You can see it right here. Click on the bullet point and hit select on the bottom window that pops up, and make sure that it is set to my controller and nothing else if you're using Blockly. If it's not set to my controller, then when you hit submit when using Webots Blockly, it's not going to submit your program to your robot. This is very important if you're using Webots Blockly. So I'm going to hit OK, and then from there I can save my world using the Save World button. Now, some quick advantages and disadvantages of block programming. Probably the main advantage of block programming is there's a decent amount of abstraction. So to actually program something, it doesn't take as many lines as it would if you were doing a text-based language. So for example, if I can have a start block, then I can just initialize the sensor in one block and then probe it in another block, right? In a text-based language, that may take a few more lines. but absolutely nothing crazy. So going a text-based language is definitely viable. It's not a huge hassle or anything. Now, the main disadvantage of using block programming is there are some features of text-based programming that aren't implemented inside this drag and drop extension. For example, in text-based languages, you can have 2D matrices or 2D arrays, depending on what language you're talking about. This drag and drop programming only supports 1D lists. So if you don't, if you want the full range of, text-based programming, then we suggest don't use drag and drop. However, if you're relatively new and you're used to drag and drop, you can absolutely do this competition just going with drag and drop programming. It's absolutely doable. Now, since this video is meant to be an introduction, we're not going to go into detail as to how to actually program with blocks or program with text-based languages. We will put links in the description of this video to YouTube videos and Webots documentation as to how to actually program robot controllers to load onto these robots. Do note that at the time you download this GitHub repository, there will be a decent amount of sample code for both blockly programming and text-based programming. So if you go into Webots and you hit restore, when you download it, there will be a few sample programs that you can load in and run just to get a feel on how to program and how Webots works. For those of you using text-based languages, you navigate to the folder that you downloaded off Webots, go to the main upper folder, and you go into controllers. There will be sample programs here for you to use. And this is actually where all controllers should be saved. So all your robot programs should be saved here. So the last thing we want to talk about is robot customization. So as we said before, we already added a few sensors onto this robot for you. We've added 3 color sensors and 2 distance sensors. And you can read all about their properties if you go to Robot, the drop-down menu, and navigate to the extension slot. And from here, you can click on each individual one, hit the drop-downs, and see what direction they're facing and everything. But since different people take different approaches to competition, we want to allow for robot customization. Now, when the official rules come out for this competition, we might limit robot customization a little bit, but there will still be some range in which you can operate. But for now, you're free to use whatever you want. So to add sensors to your robot, what you're going to do is you're going to click on the robot and go to the extension slot group that we talked about earlier. From here, you're going to go click on its children attribute, and you're going to hit this plus sign up here. There we go. And what you're going to do is the base nodes contain all the sensors that are built in by Webots by default. So for example, you can add an accelerometer, you can add in a camera, you can add in a compass sensor, distance sensor, GPS, all that kind of stuff. One thing to note that is when you add these sensors to your robot, they don't have graphics inbuilt inside them by default. So for example, if I add a GPS, you can see that if I zoom in and I drag this GPS sensor out, you can see that there's no graphic for the GPS sensor itself. It's still there. There's just no real visual representation of it. Its actual position is where these 3, XYZ axes intersect. So it's at this point right here. There's just no official graphic. So, but as long as you place it properly, it will work as intended. However, we have made some custom sensors for you. For example, if we go back to this window and you hit proto nodes for this current project, this is the 3rd bullet point, you will see a color sensor and a distance sensor built in for you. And this was made by us, and these do have visuals. So as you can see, if I drag out the color sensor, it does have a cylinder representation for you to work with. And one thing to note that the direction that your sensor faces absolutely does matter. For the most part, most sensors, they point in the direction of its red arrow. So for the distance sensors, if you click on the distance sensor, let's say the front distance sensor, you can see that the red arrow, let's go back here. You can see that the front distance sensor has a red arrow pointing out front indicating that the sensor is pointing straight. The color sensors are a little bit different though. If you click on it, it's actually facing in the direction opposite to the blue arrow. So you can see that these color sensors, the blue arrow is facing upwards, so the color sensor is facing straight down. So that basically sums up everything we really wanted to cover to get you started into using Webots for Rescue Line. I know we didn't go into detail on how to program both with Blockly or text-based languages in Webots, but any documentation, any videos, any important information that you need that's relevant for programming, you can always go to the GitHub repository and you can always scroll down to this ReadMe. And this ReadMe will be updated with all important links and documentation that you need to program in Webots. So be sure to check the ReadMe or website for any important links. Other than that, I do want to mention that there will be a live webinar and it's dated for February 6th. Any date changes will be posted on the website, but it is set for February 6th at 9 a.m. Eastern Standard Time. I highly encourage that you attend the webinar because we're going to review some of this information to get you started for Rescue Line in Webots. And more importantly, we'll be there to answer questions live. So any questions you have about programming Webots, any competition rules, or any competition aspects, you can ask and we'll answer it on the spot. So it will definitely be very helpful, and I highly encourage you to go. Even if you don't have any questions yourself, you can always listen to any of other people's questions, which is always helpful. Other than that, that about does it for this video. I hope you have a good week and good luck.